So yeah, we're going to be graphing now. Everything we do now for the next few days will be on graph paper. If you own graph paper, that's really nice. If you don't, um, you probably should find some because I'm pretty limited on the copies I can make. Thankfully, today I say in Delta Math, you don't have to have paper because it'll all be digitally graphed. But when we get to other sorts of situations where you're on your own, having a little notebook full of graph paper is a good idea. And they sell actual like binded together notebooks of graph paper for like $3 or $4, or you can just get like a like a package of loose leaf graph paper for again probably $3 or $4. So it's a good thing to have just because I'm like I said I'm limited on my copies. So I would love to just have a stack of like 500 pieces of graph paper, but I probably shouldn't do that. So for today, you can just kind of sketch to the best of your ability. But I feel like as we embark on this, the very first thing we need to talk about is just what we call the parent graph. And if you go on to take pre-calculus and other math classes, you're going to learn other families of functions. This family of functions is called quadratics. And so all families of functions, basically, they're structurally the same. Like all x to the squared, x to the second functions look the same. They all have the same shape. All x to the third functions generally look the same, x to the fourth, and so on and so forth. So the family that we're going to talk about is quadratics. And the parent graph is y equals x squared. Now, this will be the only time, other than Monday, when I have to explain this all again to the people that are gone. This will be the only time we graph the parent function. We used to call it the mother function, and that just kind of always made people, chuckle because it, sounds like something else. So, what's up, man? I missed I never actually put a heading, so I'm sorry. Do you want me? You like that when I do that, don't you? I'm sorry. So today is 11/3. I'm sorry. Thanks for calling me on that, and we're graphing quadratics. In fact, instead of saying graphing quadratics, if you want to, you can say graphing parabolas. And I know you've heard that word. I'd like to think you've heard that word before. It's Parabola. And a parabola is the type of graph that gets created by any quadratic function. And of course, right. Yeah. So all those like the Golden Gate Bridge, all those spans you see, that's all engineering using mathematics. Those are all x squared functions. So like anytime a projectile gets launched, like you shoot a rock out of a slingshot, it'll follow a mathematical pattern defined by an x squared function. So all those shapes that you see in the world, they're all parabolas. And in fact, if you ever watch, not everyone watches sports, but like if you watch like a football game, you'll see on the sideline there's a guy. Have you ever seen the guy with the big like cone shaped microphone? What it does is it's called a parabolic microphone, and it uses mathematics. The shape of that dome, it's not just something that a kid threw together. It's mathematically engineered using a parabolic shape to force all of the sound waves to bounce off of it and directly into the microphone in the middle. So these are important things as with everything I say in Algebra 2, it's not important to your daily life, but it's important to the world of mathematics and applied mathematics, right? You're not going to use it at the grocery store or when you're going to buy a car, stuff like that. So parabola is the name of the shape that you get when you graph any function that has x squared in it as its highest power. Good. So the parent function, the function from which all others will spawn, is y equals x squared. It'll get more complex. You'll see things in front of the x squared. You'll see like at the end of it, it might say like x squared minus 2x plus 5, stuff like that. But to understand the family of functions, we need to understand this graph first of all. And the best way for me to teach this to you the very first time is to make a table. Tables are super annoying, but they help us at the beginning. So real quick, just off to the side, let's make a little, you've made these before. It's a little XY table. I'm sure you've done these before. So the way we make XY tables is we just basically decide what X's we want to use, and then they give us back an output, which we call the Y value. So let's start with the most fundamental X value that there is, and I think that we would all agree that that is 0. If you put 0 into the red function, what's 0 squared? It's 0. So we can now say that there is a point on this graph named 0, 0. And we'll get to graphing the points here in a second. And then I like to just work my way upwards. What if I put 1 in place of x? Then y would have to equal 1, because if you put 1 in place of x, 1 squared is 1. What if I put 2 in place of x? Then I have to put 4. And what if I put 3? Good. And what happens with these graphs, you'll see we oftentimes don't graph a lot of points because they start to grow very, very quickly. Like if we do 4, now I'd have to go up 16. And this graph doesn't really hold that much, so we're going to just stop there. You could go forever, but again, to realistically have enough graph paper real estate, you kind of bound yourself up in a region and stay there. Now that's all fine and good. So let's plot some of those points. So I'm going to head over here and make some dots on my graph. So we agree that 0, 0 is right in the middle. It's on the graph. You can see my little red dot there. And the next point is an input of 1 is an output of 1. So that means right 1, up 1, put a dot. My next combo of input output is in 2, out 4. So you go right 2, up 4. Just plotting points like we did back in like 6th grade. And then the only other one that will fit on this particular graph, the way I have it set up, is input of 3, output of 9. So if I go right 3, I go up 1, 2, 3, 4, right there. And again, I'm out of real estate at this point. You can clearly see that that's not a straight line, right? That's why the shape, we call it parabolic, is it's always bending. It's never straight, literally never straight. You'll talk a lot about this in calculus, about how curves are always, their slopes are always changing as you move on them. So great. So if we were to sketch the graph right now, which we're not going to, it would look like this. But interestingly, we've completely neglected the other side of the coin. And that is, what happens if I put negative numbers in? Let's see. Let's see what happens now if my input is negative 1. I think this is interesting. What happens when you square negative 1? It would be positive 1. It actually reflects and kind of pings itself back upwards because squaring a negative is equal to a positive, right? All right, what happens if I input a negative 2? It again pings back up to be a positive 4. And what happens if I input a negative 3? It'll ping back up to be a positive 9. Very good. So that's the most basic table I can show you. Now, the graph really starts to take shape when we look at the points on the flip side. So if I input negative 1, it shoots back up to make positive 1. And here's where the parabolic figure sort of comes into focus. And if you go left 2, then you go up 4. Do you see how these points are dead mirror reflections across from the other ones? Now, I will tell you, once all the smoke clears and the dust settles, however you say that expression, mark my words, the hardest part of this coming up unit, once we're good to go, is drawing these flipping things. It's hard to do. And I will tell you that I'm not going to be super rude about it, but I don't want your graphs to look like these. And what happens is a lot of us, sometimes we kind of hide and say, like, I just can't draw these. And I'm not going to take that as an okay thing to say. What I find to be beneficial is I sometimes, when I'm trying to graph them, is I just sketch a little bit at a time. And then what happens invariably is it's hard. Like, I don't even like the way I connected those. So I might have to go back and then just lightly try again. And you really want to try to make it look like it's always curving. And it's way easier for you, for the record, with a pencil than it is for me on this drawing tablet. But eventually you can get the shape of curvature that you want. It just takes some persistence. And again, I'm not going to allow you to say, oh, I just can't draw them. I won't hear it. I will say some of yours will look better than others, but they should all at least look acceptably good. Never should it look like an absolute value graph, which is literally a V, like a V with a strong angle between. No. And then, of course, we're going to sketch it on the other side. And again, the same idea. Don't try to graph it all at once. I've learned that that's probably where I got that one almost on the first try. So that's one of my better ones. So there you go. For the first time ever, we have a parabola. And that's what all of our graphs for the next week are going to look like. That shape. Some of them will be fat. Some of them will be skinny. Some of them will be flipped upside down. Sometimes that midpoint will be moved around. And so that's what we're going to talk about today. So I want to get some vocabulary for you out of the way. And for that, I wanted to go to a different application. I wanted to use, you've all used Desmos before, I think. Is that correct? Mr. Manlove, I know, is really big on Desmos, and I appreciate that. So if I go into Desmos, what I did here is I hope you can see this. I can't zoom too much more. If you can't see, you'll have to probably move. I just threw in a quadratic function, and I'll show you how all this works here in just a minute, but I wanted to get some vocabulary out of the way because part of your assignment today is using vocabulary to identify characteristics of a parabola. So what I did is I asked Desmos to graph y equals x squared plus 4x plus 3. You'd have to agree that's called a quadratic because it's got x squared. And I want you to note some things and try to get this into your notes as best you can. I need to get my my writing tablet back open real quick. So give me just a sec. There it is. So here comes some vocabulary for you. First off, I want to talk about this point right here. You see that? That's like the bottom of the bowl. If the graph gets flipped, it will, of course, be the top of the arch. Do you guys know by chance what that point is called? It has a name. You use this name in geometry. It starts with a V. It's actually called the vertex, and it's going to prove to be, bar none, hands down, the single most important thing that you get out of today's lesson is finding that point. Because if you think about it, if I could find that point, if I could find the spawn point, then I can build the other points like sequentially off of him. Good. There's a couple of other points. Let's do this one first. Do you see that point? What's interesting about that point? I'm going to get rid of something really quickly. I want to kill this one so that you don't think that this is important. Good. So that point, can you see the x-axis and the y-axis now? What's significant about the blue point? It's on the y-axis. Do you guys remember from Algebra 1 what we call the point where a graph crosses the y-axis? It's got a name. It's from that. We call it the y-intercept. These are all things that you're going to be asked to do in your Delta math. So I hope you're either writing them down or committing them to memory. So far we've talked about the vertex and we've talked about the y-intercept. There are two other interesting points always, and I'm going to highlight them with some green for you. What's interesting about those two green points? They're on the x-axis, and they are called x-intercepts for the record. So I'm going to make a little note here to these 2 points right here. They're obviously called x-intercepts. You will also see them referred to as the roots. I don't want to be answering a bunch of questions about what does this mean. So again, I hope you're getting this down. The roots are also the x-intercepts. So now we've talked about all of the interesting points on the parabola. The last one, and I just deleted this a minute ago, is you agree with the parabola that it's got what we call symmetry. You learned that in geometry, that symmetry it's that reflectional symmetry. You know how you can like draw a mirror line through something and it flips onto itself up or down or whatever sideways? You should see that the parabola clearly has symmetry about a vertical line. And that vertical line, I had it graphed a minute ago. I'm going to bring it back up here again. You can see that blue line that just came into existence. Do you see how that blue line juts right up through the center? Yeah, actually, and what you can do when you get better at graphing parabolas is you can literally just graph one side of it and then just mirror all the points across, right? Because it'll always be true. All parabolas have this characteristic of symmetry. And the last one I want to define for you is the name of that line. And I'm kind of out of new colors to use here, so I'm just going to use red again. That line is called the axis of symmetry. Yep. And that's a smart strategy for graphing something. If you know it has symmetry, it's like, why work harder? Graph half of it and then flip it. It won't always save you time. These are actually pretty easy, but those are all the characteristics I need you to be aware of. So in your first part of Delta Math, it's going to say, okay, name the roots. And you have to know, oh, those are the points where it crosses the x-axis. Name the y-intercept. Name the vertex. Name the axis of symmetry. Those are all things you'll be expected to know how to do. Yeah, the y-axis in our first example would actually double as the axis of symmetry. Yeah. And you do. Good. I can't believe I was about to move on and not say that. You remember, all of you from Algebra 1, if you all took my Algebra 1, except Joe. Um, you all had me for Algebra 1. And I was real big on that horizontal lines are y equals a number and vertical lines are x equals a number. That's something I see a nodding head. You remember that. And so when we write the equation of an axis of symmetry, it will always be x equals a number. So like in this example that I have on the television, like Alyssa said, my axis of symmetry would be x equals -2. Like that's what you would type in for that. And for the points, like the roots and the y-intercept, you type in parentheses. So like if I said in this example, and I already have it on the board, but if I said, hey, name the y-intercept, you would say, oh, it's 0,3. Don't put 3. It's 0,3. It's a point. Same for the roots. Got it? All right, so there's the awkward introduction. You know that now when you graph anything with x squared, it's going to look like this. And again, they'll change physically, like they'll get fatter and thinner and they'll flip, move around, but they still look like this. That's the key. All right. So the goal here today, this will take, I have no idea how long, is to get you to be able to graph these by yourself. So I'm going to make a new page here. And I'm going to make some axes. And we're going to graph a parabola together. I'm going to show you the steps. It's quite simple. There's one little formula part that I usually have to repeat like 96 times or so. So hopefully that you'll get it down the first shot. So the first one we're going to graph together, and I say this will be difficult because you may not have graph paper at your disposal. So just do your best. We can do a lot of the math that I want you to do doesn't necessarily involve like having to count graph spaces. It's a lot of just kind of behind the scenes work. Good. Okay, so I'm going to walk you through the process of, oh, by the way, I wanted to go back. Well, no, I'll go back in a minute. I'm going to walk you through the process of finding the vertex. And to find a vertex is formulaic. That means like there's just a little formula and it's like a stupid easy formula. Like it's not, you remember the quadratic formula is like, ask a little bit. Ooh, that's a lot. It's easy. So what I need you to get in your notes, first of all, is that the vertex of a graph, a parabola, will always be found at this point. Negative b over 2a. That's the part I'll have to repeat 96 times. Opposite b divided by 2a. Got it? Now, what that little dumb formula gives me is just the x coordinate of the vertex. To find the y, I'll have to plug it back in. Just like I did in the table 10 minutes ago, I got to do the input-output thing, right? So to find the vertex of this parabola, you've seen this idea before. You need to know who's a, who's b, and who's c. So in my red function up there on the board, who's a? A is 1, right? So A is 1. And what's B? Good. And I don't really care about C. So just be advised that you can write it down. But in this formula, like I don't need it. So I'm just going to ignore it. So what is the opposite of B? So I'm going to put -12. And what is 2 times A or 2 times 1? 2. Very good. And what is -12 divided by 2? Good. So what we can now say is this. And I see you taking notes and I appreciate that more than you know. Based on that, we can now say that the vertex of our parabola is at the point -6, comma, blank. All the formula gives us is the x coordinate of the vertex. Just the x. But that's okay. Because again, going back to the table, if we have an x, how do we find a y? plug it in. Just literally plug it in. So like, let me put some little yellow boxes up here. If I change that X that I just put a box around into -6, and I change this little box right here to -6, then won't it naturally return to me a Y value? Yes, it will. That's how math works. You feed it something, it gives you an answer. So let's do some basic math here. If I know -6 is the X and I put it in the first box right here where I'm wiggling my pen, what is -6 squared? It is 36. And then I'm going to put plus 12 times -6, and then I'm going to put plus 32. That's just me copying the red equation down, but changing all the X's into -6. So for the second half, like the middle, the second third of this, what is 12 times -6? It is. So what I have now is actually 36 minus 72 plus 32. You can see at this point how disastrous it will be if you do stupid things. Like if you square a negative and get a negative, it's just not, it's going to be a waste of our time. If you forget that a positive times a negative is a negative. So you got to put all those in the past. Let those go. What's 36 minus 72? And what's -36 plus 32? So what we just did, and that's to me easily the most annoying part that you're going to face in the next couple of days, is that we just figured out that in this graph, when X is -6, Y has to be -4. Are you with me so far? Of course not. No way. The rest is super easy. What I'm about to show you is one of the easiest things I've ever shown you. You'll like this. That part sucks. So, all right, proud of us. We got the vertex out of the way. Whew, that was a lot of work. I can erase this, I can erase this, and I can now go to my vertex. I want to go there. I want to say, okay, vertex, I know where you are. And like a sixth grader would, you know how to plot the point. Where is -6, -4? In quadrant 3. Good. So I'm going to go left, 1, 2, 3, 4, 5, 6. And then I'm going to go down, 1, 2, 3, 4. And I'm very proudly going to put a big old dot there. That dot is really important. That's the spawn point. That's the point from which the arms are now going to grow out. Now I want to go back to the first graph. This is the part I was going to do earlier, and I thought, nah, let's go back and look at this one. This is where I really need you listening. It's hard. I passed my 20 minutes. Science says you get 20 minutes with kids and then they stop. I passed it. I get it. You need to listen. There's a neat growth pattern with the arms that I want you to see. This is everything. So, you know, in our parent graph back here that we did a while ago, do you see that when we went out 1, that we went up 1? Can you see that? That's neat. And that's always going to be true. Now, check this out. Do you also agree that when we went out, I'm saying out because we're going left and right. It's that symmetry idea. That when I went out 2, how far up did I go? Nice. And I'm highlighting these with colored lines for you so these get stuck. These numbers are so important. And when I went out 3, how far up did I go? And if you ever forget these numbers that we're about to talk about, they are just the squares, dudes. They're just 1 squared, 2 squared, 3 squared. So what is the length again of this first vertical line? 1. What's the length of the second vertical line? 4. What's the length of the third? 9. And there, guys, is your ticket to just smoking through parabolas for now. Is that 1, 4, 9? What would be the next vertical line if I had room? 16. But I don't have room. And that's okay. So here's the good news. If I know my vertex, let's go back to the other graph now. If I know my vertex is at -6, -4, I don't need to do any more math. I know that the graph opens upwards, and we'll see, we'll do this in the next example. But do you see how right here in front of x squared, how it's not a negative? I know then that my arms go up. It opens like a bowl. So when I leave my vertex and I go out 1, how far up should I go? Yes. So I'm going to go boop, boop, and the parabola starts to form itself. When I go out 2, how far up will I go? Boop, boop. When I go out 3, how far up will I go? Good. Boop, boop. And there's your parabola. Done. You can see that the lion's share of the work is finding the vertex. And when I say lion's share, I mean like 95% of the math is finding the vertex. And then the points, well, that's easy. Light work. And again, your job would be to graph that. Now, when you do this in Delta Math, you just, as soon as you plot 5 points, it constructs the graph. You put in 5 points, it makes it. So that's the good news. You don't have to try to sketch it today or anything like that. You'll click. Let's do another one, but let's do it inside Delta so you can kind of see what you're going to be up against. So for this, I'm going to go a little bit off the script here, but let me show you what it's going to look like. So if I go into graphing parabolas, let's do like level 1. Can you all see this okay? Get a little bit more zoomology for you there. Let's do this one. We'll do a couple. And again, you got tons of work time coming up on Monday, so don't worry about the clock. Are you still with me? I haven't lulled you to sleep yet? Nice. So you can see the function up on the board, and let's do our thing. Obviously, step 1 is to find the vertex. And remember, please, that the vertex will always be found at, what's our happy little formula again? Good. Opposite B over 2A. And so we're going to work that out real quick. So I got to get my proper pen here. Okay, what's A? What's B? Good. Remember, we don't give a rip about C. We use C to find the vertex eventually, but we don't need to write it down. So to do opposite B over 2A, remember the formula we wrote down? I go positive 6 over 2 times 1. And what's 6 divided by 2? So remember, the vertex is now, there it is. We just don't know it all. So we're going to take the 3 and we're going to put it back up in place of the x's and figure out the y. What's 3 squared? 9 minus what's 6 times 3? Plus 5. So I'm just doing the function with the x's turned into 3's. What's 9 minus 18? Negative 9 plus 5. So this is huge. This means now that I can go, watch how this works in Delta. I can go to the point 3, negative 4, and just click and it makes a point. Obviously, there's no parabola yet because it's like, it's not enough information. It won't even have enough information when I do 2 more. Now, notice in front of the x squared, it says positive 1, right? So that means that the arms go up and not down. So when I go out 1, how far up do I go? Out 1, how far up do I go? So remember, out 1, up 1. So see, I did it twice, once on each side, but it still hasn't made a graph. When I go out 2, how far up do I go? 2, 4. I'm going to go point. There's still no graph. Still no graph. You ready for it? It makes a graph. And that's that 5th point. So it wants the vertex, and then it wants 2 and 2, and then it'll make a graph. Huh? When will it? Yeah, it'll open bigger. It'll open like fat. It'll open skinny. We're not going to cross that bridge until next week. So today we're smooth sailing on the easy ones. When the graph changes, like its physical structure, when it gets fatty or thinny, is when there's a number in front of x squared. And the only thing that'll be in front of x squared, like our next example, will be a negative sign. And what do you think that does again? It flips it. But structurally, it's all still the same. You still got your mid, and then you're out 1, down 1, out 2, down 4, out 3, down 9. Like that pattern ain't going to change today. So let me find one that has a negative opening direction, and then let's see, new problem. Oh, perfect. Let's do this one. So I'm going to try to zoom us a little bit more. Control plus. There we go. So you see the function there. What is A? So A is negative 1. And what's B? So let's do our mathy thing. We got to do opposite B over 2A. What's opposite B? What's 2A? It's not, you gotta really hold yourself accountable for the details here, right? It's what you're learning. That's what math's all about. Gotta be as perfect as I can be. What's negative 12 divided by negative 2? So we know the vertex, here it is that 6? Don't know. That's okay. Now, watch out for this next step. You're in high school, so what I'm about to show you should make perfect sense. When you take 6 and you put it in place of x, watch out. This is part of the lesson that I would highlight as important. If you put 6 in place of x, it only goes there. Notice I'm not including the negative sign. It is not negative 6 squared. It's the opposite of 6 squared. That pause was on purpose. So you do the 6 squared. What is 6 squared? It is 36. And then you apply the negative and you get negative 36. I know you might want to say, well, I thought when you squared it, we're not squaring a negative. We're squaring 6 and then putting the negative on it afterwards. And then let's put 6 in place of the second one right here. What is 12 times 6? So I have plus 72 and then minus 35. And what is negative 36 plus 72? And what is 36 minus 35? It is positive 1. So if all of that has gone well to this point, you now know that your vertex is at the point 6, 1. Good? Yeah, the name of the vertex has no bearing on its opening direction. The opening direction is completely determined by that minus sign right there. It doesn't care about the vertex. Good, good. Okay, so let's get to it. Let's go make a graph. What did we say the vertex was at? 6, 1, right? So I'm going to head across to 6, 1, and I'm going to make a point. That's right 6, up 1. Now, when I go out 1, where do I go? Down 1. Good job. When I go out 2, where do I go? Down 4. And then when I do this next one, boop, it's done. And then I submit that, and it gives me the big green check of happiness, and that's that. The other part of today's assignment is parabola features, and it's going to look like this. It's going to say using the graph, determine the coordinates of this, or determine this. And so what are the coordinates of the vertex in this case? So I just type in 1 point, and then I type in -3, tab, -1, submit. Good job. Let's find another one. Determine the coordinates of the roots. What are the roots again? Right. And so this time there are 2 of them. Do you agree? So I'm going to go down to my drop down and I'm going to pick 2 points and then I'm going to name them. I got to zoom out just a little so we can get everything in the picture here. Give me one of the zeros, the roots. So -5, tab 0, and then -1, tab 0. And you submit that. So this first part of your assignment is just familiarizing you. So this time you see how it says x-intercepts? Those are roots again, right? Just different vocab. Vertex, easy. X-intercepts again. Oh, y-intercept. What's the y-intercept of this graph? It's 1 point, and it's right here where I'm moving my pen. I know it's hard. It's hard to zoom enough to make this work. Let me see how. Let me get you guys a little more zoomology. You see it? This is the y-intercept, so we name it 0 first, tab -8. Good. And then the only other one I wanted to find for you was axis of symmetry, and it doesn't show up very often, but it'll pop up. There it is. So it says using the graph, determine the equation of the axis of symmetry. And you can see that the axis of symmetry, this is going to be a really bad sketch, but you can see that it goes right down like this, right? Sorry about that. So how would I name that axis of symmetry? No. X equals -2. So for the answer type, I would pick one equation and I make sure I do X equals, because it's vertical, -2. So that's kind of what today's assignment consists of, is the vocab part and then a lot of graphing and vocab kind of put together. It should not be a difficult thing. I don't know, 30, I think. That's why there's work, I know. That's why there's some more work time for you on Monday. Any questions about that? Right. So again, this assignment I have due, I don't remember what number it is. You'll figure that out. It's due, a Tuesday at the start of class. That's when we'll call it done.